Hello, I'm Ali, and this is the second video on set theory. In this video, we will cover the notion of the complement of a set. There are three steps we will follow. 1. Understanding the meaning of the reference set and the complement of a set. 2. Exploring the relations between complements of sets. 3. Discussing the sizes or cardinality of specific set operations. Consider a football player who is part of a club in a league consisting of 20 teams. Let's picture this football team with 30 players in the current season. So, calling this set A, the number of members in set A is denoted as 30. Now, if someone asks how many individuals are not in the same set, one might mention the manager, the fitness coach, the goalkeeper coach, and other backroom staffs, which is correct. However, there are alternative responses. One could argue that players from other clubs are not members of the same set, and that's correct too. Another perspective might be that all athletes not playing for the same club are not part of the set. Similarly, one might assert that individuals from the city, that country, or even other human beings on planet Earth are not members of this set. Therefore, it becomes crucial to define a reference set when tackling problems or exercises in the field of set theory. To better grasp the idea of a universal or reference set and complement set, let's take a look at this diagram. The universal set is like the big space where everything happens. Our set is just a specific part of this big space, and the complement set is what completes our set to make up the whole universal set. This is a simple exercise to practice finding the complement of a set. We have a universal set denoted as U and a set presented as A. To find the set that completes the universal set, we subtract set A from the universal set, and the result is the complement set. Now let's solve the same exercise with the new universal set. In this case, our universal set is the set of integers instead of natural numbers. solving the identical exercise with another universal set in this exercise, or provides another answer of a complement set. In all three exercises, even though set A remains the same, the complement set differs due to the use of different universal sets. This emphasizes the significance of the universal set and underscores the importance of being aware of which universal set we are considering in our exercises. Here's another exercise asking us to determine the complement set for two given sets A and B with respect to the universal set being the set of real numbers. Remember, the most effective tool for these types of exercises, especially when dealing with multiple sets or finding complement sets, unions, or intersections, is the real number line or the line of any other universal set defined by the exercise. I've outlined set A in red on the line, so the complement set is what remains on the line. In the third part of the exercise, to determine the complement set of the union set of A and B, we first identify and trace the union set. The remaining part naturally constitutes the complement set. In general, there are important relationships between the complements of two sets and operations such as difference, union, and intersection. In the next videos, you will see the mathematical proof of these relationships. For now, we will demonstrate them through some examples. To do that, we first define a reference set as U and two of its subsets as A and B. Now let's examine the possibility of the second relationship. You will be able to test the validity of the other three relations using the same universal set and its subsets. In general, the first rule states that the complement of a set is equal to the set itself. The second rule states that the set of elements not present in the union of two sets is the same as the set of elements absent from both A and B. The third rule states that the set of elements absent in the intersection of two sets is the set of elements absent in either A or B. These last two rules are called De Morgan's laws. The final rule states that the set of elements in A but not in B is necessarily the set of elements in A but not in B. Now, in this part, we will explore the cardinality of a set after it undergoes a set operation. If we add the cardinalities of two sets and subtract the cardinality of their intersection, we obtain the cardinality of the union set. You might ask why we subtract the intersection. Good question. It's to prevent the common elements from being counted twice, as they are included in both set A and set B. Then, to calculate the cardinality of the difference between two sets, you simply subtract the number of common elements from the cardinality of the first set. And finally, to obtain the cardinality of the complement of a set, we subtract the cardinality of our set from the cardinality of the universal set. Now let's solve some exercises to see how to use these formulas. I've provided this toolbox so you can decide which tool to select for each part.